Okay, so for the second part of today's lesson, we're going to talk about 45, 45, 90-degree triangles, and we're just kind of look at a pattern. So first thing is just if I take a square that has 90 degrees, all the angles are 90 degrees in a square. And if I draw a triangle, my first note is to show that this is going to be a 45, 45, 90. If two sides are the same, these angles would have to be the same. If this is 90 degrees, then these would both have to be 45 degrees. So they make these are isosceles right triangles. Okay, so I'm going to go through Pythagorean theorem with these. Some of you are going to go through it in class to find out what x is. So this is going to be 10 squared plus 10 squared is equal to x squared. 100 plus 100 is equal to x squared. 200 is equal to x squared. X is equal to the positive root of 200. I simplify. Oh, that's interesting. And so 200 divided by 2 is 100. I know the square root of 100 is 10, so all said and done, this ends up being simplified to 10 radical 2. Okay, so this is 10 radical 2. Don't forget your units. In this case, it's centimeters. I do the same thing for the next one. 6 squared plus 6 squared is equal to x squared. 36 plus 36 is equal to x squared. 72 is equal to x squared. X is going to be the square root of 72. We simplify. 72 divided by 2 is 36, and this right here is a perfect square, so this is going to be 6 radical 2. Okay. And then my last one, if you kind of follow the pattern, the side was 10, it was 10 radical 2, the side was 6, it was 6 radical 2. So I think probably, if this is x, this is going to be probably 2 radical 2. So I go through, it's going to be 2 squared plus 2 squared just to make sure my conjecture is correct. 4 plus 4 equals x squared. Now, some of you will really notice that every single time I'm going to end up having two perfect squares, which is where I have like radical 72 is actually 36 times 2, right? And so I have my perfect square, and then the 2 left over. This one was 200 is 100. I don't know what is going on. 100 times 2. And so I have my perfect square and I have my 2 in theory. So this is going to be 8 is equal to x squared, and I know 8, I take the square root, 8 is actually 4 times 2. And so it ends up being, sure enough, it's 2 radical 2, and I'm not going to forget my centimeters here. This is 2 radical 2 centimeters here. So that's the biggest conclusion. So for 45, 45, 90, here is my leg, here is my leg, and here is my hypotenuse. If this was x, this was x, then my hypotenuse would be x radical 2. Okay? And so what you really need to know is your hypotenuse in a 45, 45, 90 is always equal to your leg times radical 2, and I do h equals leg radical 2. And so if you can remember that, and you guys have it a lot easier this year because you're virtual, you don't have to memorize that, that's going to carry you through the rest of these examples. So for the next one, I know my hypotenuse is equal to my leg times radical 2. Some of you can, right away, if this is 8 radical 2, you knew that this was going to be 8 and this is going to be 8 because it's my hypotenuse. And so x is equal to my hypotenuse, was equal to my leg times radical 2. If we were doing this algebraically, you divide each side by radical 2, and of course x is going to be 8. In this case, centimeters and centimeters. For this one, if my hypotenuse is 3 radical 2, then this is going to be 3 and 3. Okay. For this next one, it's just a little tricky. This is not simplified, so I mean that's part of the issue as well. But even if you don't, I know my hypotenuse is equal to my leg times radical 2. I divide each part by radical 2. Now this just kind of gets into your rules of radicals. Actually, if both of them are under the radical symbol, I can divide like normal. So this is radical 4 is equal to x. X is equal to 2. Now see what happens is radical 8 is actually radical 4 times 2. All right, my next one, I'm given the hypotenuse. Okay, my hypotenuse is equal to my leg times radical 2. I divide each part by radical 2. I divide out my radicals because they're both in a radical, it's okay. So this is going to be 5 radical 3 is equal to x. And since this is going to be 5 radical 3, this is going to be 5 radical 3. This is where it gets a little bit tricky, and this is probably a little bit more foreign concept to you, so hopefully you can practice this a little bit. So I know for this one, I know my hypotenuse is equal to my leg times radical 2. Okay, and so I divide out by radical 2, I divide out by radical 2, but I can't divide these out because the 8 is not in a radical symbol. So I have x is equal to 8 over radical 2. Now we have a problem here. You cannot have a radical in the denominator, so I have to do what's called rationalize the denominator. I have to get rid of that. And it's actually pretty simple. So all you have to do to rationalize is you just multiply by the radical over the radical. This is called rationalizing the denominator. Okay, it makes it so when I multiply across, I end up with 8 radical 2 over radical 4, which is going to be 8 radical 2 over 2, which is much nicer, and 8 divided by 2 is 4. Okay, and so this is equal to x. So this is going to be 4 radical 2, this is going to be 4 radical 2 centimeters. And this is actually a second, and I'm going to show you this pattern. So my hypotenuse is 8, my leg was 4 radical 2. So I do the same thing here. I know 6 is equal to my leg times radical 2. Divide by radical 2, divide by radical 2. 6 over radical 2 is equal to x. Multiply by radical 2 over radical 2 because I'm going to get rid of my radical. 6 radical 2 over 2 is equal to x. 6 divided by 2 is 3. And that's my answer. This is going to be 3 radical 2 centimeters, and this is going to be 3 radical 2 centimeters. Again, a lot of you might ask, well, why is this just plain 2? Anytime you multiply a radical by itself, you end up with that number. So that's why radical 2 times radical 2 is radical 4, which is just plain old 2. And I know that that's one of your gaps. Just try your best, and we'll keep talking about stuff like that. So there is also another formula that some people see, is if I take my hypotenuse, divide by 2, and multiply by radical 2, then I get my leg. So there's also my leg is equal to my hypotenuse divided by 2 radical 2. I don't usually teach this one. It's a pattern that you can see. This is the one that I always go to just because it's simple. It's just one thing to remember. Hypotenuse is equal to leg times radical 2. So for this next guy, it's a solve for the missing parts. If this is 45 degrees, this also has to be 45 degrees. So if this side's 12 radical 3, then this side also has to be 12 radical 3. I know my hypotenuse is equal to my leg, 12 radical 3 times radical 2. My hypotenuse and I can multiply the radicals is 12 radical 6, and I can't simplify, so that's my only answer, and that's my exact answer. This one it says determine the exact area, so I need to find the measures of the sides. I know my hypotenuse is equal to my leg times radical 2. I divide by radical 2. I can divide those out. This is going to be 10 radical 3 is equal to my leg. So each side is 10 radical 3 and 10 radical 3. My area is length times width, so it's going to be 10 radical 3 times 10 radical 3. 10 times 10. So my area, 10 times 10 is 100. Radical 3 times radical 3 is just plain old 3. So my area is going to be 300 units squared. Okay. This one's actually not so bad. Perimeter of a square is 8 feet. So if the perimeter was 8 and it's a square, then each side must have been 8 divided by 4, which is 2. So 2 feet, 2 feet, 2 feet, and 2 feet. What's the diagonal? Well, the hypotenuse is equal to my leg times radical 2, so it'd be 2 radical 2 feet. And